Welcome back. Have you ever just stopped and wondered what's really holding the internet together? I mean, all of it? Today, we're going to pull back that curtain and demystify the core technologies that make every single website you visit actually work. All right, let's get right into it.
So what are they? What are the fundamental building blocks of the modern web? That's the big question we're diving into today. And trust me, we're going to break it all down, piece by piece.
And we've got to start at the very beginning, with the absolute foundation of literally every web page out there. Let's talk about HTML. You can think of it as the web's skeleton.
So, HTML. It stands for Hypertext Markup Language. And yeah, it's pretty much the native language of the internet, brought to us by the one and only Tim Berners-Lee. But here's the key part. Why is it called a markup language? Well, it's because it uses these things called tags. You know, keywords wrapped in these little angle brackets to tell the browser how to structure the content on the page.
For example, take a look at this. The H1 tag, that's your go-to for the biggest, most important heading on a page. And HTML actually gives you a whole family of them, a full hierarchy from H1 all the way down to a tiny little H6, which lets you organize your text and show what's most important.
And here are just a few more of those essentials. You've got the A tag or anchor tag for making links, IMG for, you guessed it, putting in an image, BR just gives you a simple line break, strong makes text bold, but it also tells search engines that this text is important. Then you have OL for a nice numbered list, and TR for defining a row inside a table. These are like the Lego bricks you use to build pretty much any web page.
Okay, so we've got our skeleton, right? Now we need the brains to make it all work. Because while some things happen in your browser, a ton of the heavy lifting and logic happens behind the scenes, on a server. And that's where a powerful language like Python comes into play.
Now you'll hear Python called a high-level language. What does that even mean? Well, it's actually pretty simple. It just means the code is designed to be way more readable for us humans. It hides all the super complex, nitty-gritty details of the computer's hardware. It's really the opposite of a low-level language like assembly, which is way closer to the ones and zeros the machine understands, and, much harder for us to write.
And Python didn't just appear out of thin air, It's got a pretty rich history. It was created by Guido van Rossum. And this just helps put that into perspective, showing some of the other giants of the programming world. Dennis Ritchie, who gave us the C language, James Gosling, the father of Java, and Bjarne Stroustrup, the creator of C++. Pretty legendary company.
Every language has its own little signature. And for Python, you can always spot its files by the simple .py extension. And when you're writing Python and you just want to see the output of your code, the most basic fundamental command you'll use is print. It's simple, it's direct, and it just works.
Okay, so we've got structure with HTML, and we've got some server-side logic with Python. But what about the stuff that makes a website feel, well, alive right there in your browser? That's where our next building block comes in, JavaScript. This is the key to truly interactive web pages.
I mean, its whole purpose, right from the beginning when Brendan Eich created it at Netscape, was to make web pages interactive and dynamic. Now, when we say dynamic, what we really mean is that the page can update its content all by itself without you having to smash that refresh button. Think about live sports scores on a page or a stock ticker that's constantly updating. That's JavaScript at work.
And here's a cool little detail. Developers always need to leave notes for themselves, or other developers, right inside the code. We call them comments, and the computer is programmed to just completely ignore them. And what's kind of funny is that each language has its own secret code for doing it. Python uses a hash symbol, JavaScript uses a double slash, and HTML uses this very specific arrow and dash combo.
So we've built a page, we've made it interactive, but none of that matters one bit if it can't get from a server all the way to your screen. And that brings us to the final, absolutely critical piece of the puzzle, networking. This is all about connecting the dots.
And that leads us to a really fundamental question. How does data actually make that journey across the vast, tangled web of the internet? The answer, or at least the roadmap for the answer, lies in a framework called the OSI model. It basically breaks down a super complex process into more manageable layers.
Now, we're not going to go through all 7 layers today, but this gives you a peek at some of the really crucial ones. At layer 4, the transport layer, our data is called segments. Then, at layer 3, the network layer, it's broken into packets. And way down at layer 2, the data link layer, it's called frames. It's like the data gets a different name for each leg of its journey. let's just zoom in on layer 4 for a second. The transport layer is so important that people often call it the heart of the OSI model. And that's because it handles these mission-critical jobs like flow control, so your computer doesn't get overwhelmed with data, and error control to make sure everything arrives in one piece. It's also in charge of segmentation, which is that process of chopping up big files into those smaller segments we just mentioned.
Okay, so for data to find its way, it obviously needs an address, right? In any network, part of an IP address is used to identify the entire network. That's the network ID. And the other part identifies a specific device on that network, like your laptop. That's the host ID. It's kind of like a street name and a house number.
So because of how this addressing works, a standard Class C network, which is a super common type for smaller setups, can have a maximum of 254 usable devices or hosts. Now you might be thinking, wait a minute, why not 256? And that's a great question. It's because 2 addresses are always kept for special purposes. One for the network ID itself, and another one for broadcasting a message to every single device at once.
Finally, let's talk security. How do we keep all this communication safe? Well, that's where HTTPS comes in. It's the secure version of the web protocol you see all the time. It usually communicates over port 443, and it relies on encryption protocols called SSL and TLS to work. And where does this fit into our model? All that encryption and decryption, that's the main job of the presentation layer, which is layer 6 of the OSI model.
So, there you have it. From the HTML skeleton to the programming brains to the networking that connects it all, we've looked at the absolute core building blocks of the web. The only question left is, now that you know the pieces, which part of this incredible digital world do you want to explore next?